In this video, we will discuss about how to find rank of matrix using echelon form. In the previous videos, we have discussed how to find rank using minor method, and we have also solved few examples. In this video, we will see what is echelon form and how to reduce a matrix into echelon form and then find out the rank of that. So here are few conditions which you need to always remember. Basically, these are rules which help us in identifying whether we have converted or reduced our original matrix into echelon form. So a matrix is in reduced form or reduced row echelon form when it is satisfies the following conditions. So there is also two types of echelon forms. One is a row echelon, another one is a column echelon form. So we will discuss about row echelon form while solving a linear set of equations and everything, and also finding rank in wherever we get a problem. So we will discuss row echelon form. So these are the three conditions for row echelon form. The first, non-zero element in each row is called a leading entry. So in below you can see there are two matrices as examples. So these two are already reduced into echelon form. So I have kept it to idealize it for these conditions. So first one is first element in each row is called a leading entry. For example, we have to look from this side, and here one is called the leading element in the first row, and here one is called the leading element of second row, and this one is called the leading element of third row. Okay, and each leading entry is in a column to the right of the leading entry in previous row. Okay, so for example, let's consider I and I plus 1 row. This is I row and this is I plus 1 row. So if you observe these two elements, it is clear that the second leading element or second row leading element is to the right of the previous leading element. So this should be valid for all the continuous row downwards. For example, if you see this third one, it is to the right of second. And in the similar way, you observe this matrix. This is first leading element of first row, leading element of first row, and this is the leading element of second row. You can clearly see that it is right to the previous one, and this third is also right to the previous one, and this is the second condition to be in echelon form. And third one is rows with all zero elements, if any, are below rows having non-zero elements. So if there is any row which completely consists of zero elements, it must be at the bottom of the non-zero rows. For example, you can see here 0 0 0 0. So it is to the complete bottom or below all the non-zero elements. And similarly here also there are four. This is the zeroth or null row. It is the bottom of all the non-zero rows. So these three are the conditions, and we have to always keep this in mind. So while reducing a matrix into echelon form. Now in the further part of video, we will reduce a particular matrix into echelon form and find out the matrix of that. And the main intuition behind is finding the rank first, and then in the next video we will discuss about how to find solutions of linear equations, whether the solution exists or not based on rank. So let's take one example. So how to convert a matrix into echelon form is by using some elementary operations or elementary transformations. Okay, I will tell 3 to 4 examples which make you clear to understand the rank of matrix. How to find the rank of matrix. And the first one is let's take a matrix A of which is having elements 1 2 3 2 3 4 3 5 7, and please remember some few rules how to convert a matrix into echelon form. So first thing to keep in mind is convert the last two elements to 0, or transform these two elements to 0 first. Okay, this is the first point to remember. And for that, what we need to do is R2 tends to R2 minus 2R1. Okay, so this is the first rule. And next, R3 tends to R3 minus 3R. Okay, and the transformed matrix after these particular elementary transformations is 1 2 3, and these two elements become 0, and next these become R2 minus 2R1, 3 minus 6, is it correct? 3 minus 4, that is minus 1, and next 4 minus 6, that is minus 2, and here we get minus 1, and again here we get minus 2. Okay, so this is after transformation. And next thing is we need to reduce these particular elements to 0. Okay, I mean, first give preference to this one. We need to reduce this element. Okay, let me rub this first. Okay, so next reduce this element to 0. So this is for this method is for 3 into 3 matrix. Next reduce these elements to 0. For that, what we need to do is just we can add these two things. Okay, R3 tends to R3 minus R2, and this will result in minus 2, 0 0 0. Okay, so this is automatically converted to 0, and if it is not converted, in next step you convert this element to 0. Okay, if it is not converted to 0, in the next step you need to convert this element. Okay, and we have completed with this. Next check whether this is in echelon form or not. Okay, what are the three conditions? Everything is having leading element, and the element at start or the previous row is I mean, let us consider this as ith row, and this is I plus 1 row, and I plus 1 element is to the right of the previous one. And if there are any non-zero elements present, I mean 0 row present, that should be present at the bottom. So this is in the echelon form. And if you want to change this particular element to 0, it cannot be done because this value gets altered, and that will be if this value get altered and changed into any integer, this will not be in the echelon form. Therefore, rank of this I mean number of non-zero rows is 2. So rank of A is also equal to 2. That equal to number of non-zero rows. Okay, and we will solve another example. Now we will solve a 3 into 4 matrix. 0 1 2 1 1 2 3 2 3 1 1 3, and what we need to do first is we need to convert these two elements to 0. Okay, first thing. So here is already the first row is already containing 0, so just exchange it. That means R1, I mean interchange it. So this converts to okay. So we have converted this place to 0, and next this place. So R3 tends to R3 minus 3R1, and this makes the matrix to zero. This will be minus 5, 1 minus sorry, here 1 minus 3 to the 6, minus 5, and this one will become minus 8, and this is a minus 3. Okay, now after this we need to after completing these two things, we have to make this element to 0, and for that what we need to do is R3 tends to R3 plus 5R2. And this makes 1, 2, 3, 2. Here 0, and this one becomes 0. And this will become 2. And this also become 2. Okay. So is it possible to reduce this one to 0? I mean these two elements to 0? If we do something to these two elements, I mean if we do something to this element, what happens is, for example, if I want to reduce this element to 0, what can I do is R3 tends to R3 minus R2. Okay, so what will this operation results in? Okay, this operation results in 1 2 3 2 0 1 2 1, and you can see this will become 0, and 0 minus 1 is minus 1, and 2 minus 2 is 0, that's fine, and 2 minus 1 is 1, that's fine. But this is not in the echelon form. So what is our rule? If there is a leading element, you can see this is the leading element, this is the leading element, and this is the leading element. So this is the I plus 1th leading element, this is ith leading element. So this is exactly equal to the previous row element, but that should not be true. The next leading element row should be right to the that of the previous row. Okay, if you consider this as I plus 1, I row, and this is I plus 1, I plus 1th leading element should be right to the ith leading element, ith row leading element. So as this is failing as this is failing the echelon form condition, so we cannot further reduce it. Okay, we cannot make this element to 0. So the rank of this matrix is equal to, as there are okay, rank of matrix is equal to number of non-zero rows, non-zero rows. So we are having here 1 2 3 non-zero rows. So rank of A is equal to 3.